Hello. Sorry, shared totally the wrong screen there. Um, cool. So, hi, I'm Ben. And if you are at all into neural audio synthesis, the last week has been really fun because we hosted NASH, the first ever neural audio synthesis hackathon. The idea is basically hackathons are a really great way to kick off collaborations, get people inspired about a topic. And since there's been so much exciting and accessible work in the field of neural audio synthesis recently, it felt like the right time to host one because there's been a lot of new work, a lot of impressive new models being released, but it's not always totally clear how these can actually be useful or impactful to, say, musicians, artists, sound designers, etc. And there are some artists now at the intersection of music and AI research who are starting to apply this technology in their work, but there's still a lot of exploring to be done into the creative possibilities. And probably more importantly, the technical barrier to entry is super high. So hackathon participants were really encouraged to think about tools and techniques and interfaces that might be useful down the line for creative applications. So after announcing the hackathon, I was really bowled over by the positive response. And in particular, a couple of very generous members of the community offered to give tutorials to help people get up and running with some neural audio synthesis models. And so we decided to put together a sort of pre-hackathon workshop. This was a 2-hour-long event the weekend before the hackathon. We heard from 5 speakers. We heard from Hugo Flores Garcia about a pipeline for almost instantly deploying PyTorch models to Audacity. We heard from CJ Carr from DataBots about how they do their infinite AI death metal magic, amongst many other things. We heard from Ilaria Manco sharing her work on Word2Wave, which is like a text to audio synthesis tool using Koala and WaveGAN. Moises Ota talking about how he uses neural audio synthesis in his creative practice. And finally, Antoine Caillon talking about Rave, the real-time audio variational autoencoder. It was a super fun event. The talks were really, really inspiring, and there was loads of engagement and insightful questions from the audience, and over 100 people registered, which was just really, really cool to see. And then the following week was the hackathon itself. And again, like, was really overwhelmed by the interest. 76 people signed up. Somehow we ended up with 85 members in the Discords. I guess some people may have joined twice. And the hackathon started with a week-long brainstorming phase. So participants pitched projects and discussed them on a shared Trello board. And ultimately, that led to 48 hours of hacking on last weekend, the Saturday and Sunday just gone. And after that, 9 projects were submitted from about 20 participants. Some more were underway, but didn't quite make it to being submitted. But I'm told some cool learnings were made. So these are the projects that were submitted. Sadly, we don't have time to go through them all individually now, but I'm going to share details at the end of this talk on how to find out about them. And I really, really recommend you do, because some really awesome work was done. But after the hackathon concluded, there were 24 hours to vote on the submitted hacks in 3 categories. And I'm very happy to be able to announce the winners to you now. So in the category of best idea/research direction, we have Rave Audition by Andrew Fife and Bogdan Teleaga. And they also won Best Code and Implementation. And then in the category of best ideas, wait, I've messed something up here. Okay, best presentation and demo went to Rave Audition. Best Code and Implementation went to Rave Audition. And best idea research direction went to Trying to Do Time Alignment by Scott Hawley, Jacob Stellings, and Matthew Rice. And so what I'm going to do is I'm going to play 2 minutes each of the videos they submitted as part of their submission for the hackathon, because I think that'll be a lot better than hearing me ramble on about their projects. So first up, let's check out Rave Audition.
My name is Andrew. I've been working on this real-time implementation of Rave, which was done by Anton. So here it is here. I've done a wee screenshot of Rave here. It's called Rave Audition because I guess the whole premise behind this was that you can audition your Rave models. You can dynamically, at runtime, import new models and hear how they sound and experiment with a live audio input from the DAW. You can also toggle it to use the prior mode where It's essentially just infinitely creating new samples from whatever model that you're using, which is really cool. And you can hear how the textures change as you manipulate the heat parameter, which is like this temperature parameter that Antoine's like exposed there, which can be really cool to play about with. So I'm going to show you a wee demonstration of this. So if I've loaded in some drum loops here, you can just hear how that sounds, kind of lo-fi drum beats. I'll load up the instance of the plugin. We need to then load a model. So there's a selection of pre-trained models here that Antoine did. So we could, just for starts, I suppose we can start with like maybe the speech model. We can load that, and then we can listen to how that sounds. So yeah, quite interesting sounds there. Like I was saying, we can change to the prior mode.
Yeah, afraid and
he's
he's used to use your own things of different ideas, so what
does its own thing, and you can change up the heat parameter.
Cool. Yeah, definitely go check out the rest of that video when you get a chance, because yeah, Andrew and Bogdan did some amazing work there. Then we have
I've been working on the
trying to do time alignment from Scott, Jacob, and Matthew.
Hello and welcome. We are the Time Alignment Group. The idea for our project was to have time alignment done by a neural network. And the prior precedent on this was some work called Signal Train, where in a very simplified scenario, the network was able to learn, for example, a late or early drum hit or guitar pluck. It could learn to move things onto what was regarded as the grid or a particular spot in the audio. But this was a very simplified scenario. It was never fully investigated, and so we wanted to look into it in greater detail. And instead of using the Signal Train model, we were going to use a model from Christian Steinmetz. We chose Micro TCN because some of us have some experience with that. It's an audio effect kind of model. And so what we did was, first of all, we had to create a data set. And just really briefly, I'll show you the idea behind all this was, this is an input. We have a click track and we have some randomly timed stuff, right? And then the idea was the target would then be all lined up. All right, and so creating the data set was something that Jacob worked on. So I'll let him talk about it a little bit.
Yeah, so for this data set, we used Fraunhofer Institute guitar pluck data set that was used by Marco Martinez. We just grabbed that and downloaded it and then did some resampling. So we worked at sample rate of 16,000 just to reduce like the bloat of stuff. And then we basically took each item in that data set is just one guitar strum or guitar.
Okay, and that's all you're getting for now, but definitely go check that out as well, because again, some really cool work.
Hello.
And one little bonus is just before DMRN this morning, I saw this post on Twitter. Someone has already installed Andrew and Bogdan's model and started doing real-time voice to Darbuka transfer in their DAW. So you can see within days of this being made during the hackathon, this is already actually having an impact on how people use neural audio synthesis creatively, which is just awesome to see. So I think, yeah, just shows why these sorts of events can be helpful. So we're definitely going to be doing more of these events. So keep an eye out. I'm going to be sharing about them on all the usual sort of mailing lists and communication channels. So yeah. Thank you to everyone who participated. Congratulations to all the winners. If you want to go check out the projects, they're going to be up soon on the Nash website. But right now, I've also posted a thread on Twitter I've done this URL shortener. I'll post it in the chat as well, where you can go watch all the videos and there's little descriptions of them. Yeah, really worth taking the time to check them out because, as I said, some awesome work was done. Cool, and I think that's almost exactly 10 minutes, so I'm going to shut up there. Thank you.